In this lesson, we are going to learn Bragg's law. In solid crystals, the atoms are arranged in planes like this, regular planes. This is true for common salt and most metals. Now, if you make X-rays fall on this at an angle, now X-rays will get reflected from this plane and this plane. Right? These crystals can act as natural 3D gratings for diffraction of X-rays. Now these X-rays fall here, get reflected, this is falling here and getting reflected. This X-ray is travelling this much extra distance. The path length difference we can easily get, this is d, so this will be d sin theta, this is theta, this is also theta. So this is d sin theta, this also is d sin theta. Therefore, the total path difference is 2d sin theta. And if this 2d sin theta is an integral multiple of lambda, then we will get constructive interference. So now we can vary this angle theta till we get constructive interference. We will use some monochromatic X-ray and vary the angle theta till we get constructive interference, that means the light, the X-rays will get strongly reflected. Now, once we get that, then we can find d, because we know lambda, we know theta, that will get by experiment, we can find d. So this is what is Bragg's law. 2d sin theta equal to n lambda will give you strong reflection of X-rays, constructive interference. By using this, we can find the interatomic spacing and we can also get the structure of the crystal. So this is one use of X-rays. What are X-rays? X-rays are electromagnetic waves having wavelength from 0.1 angstrom to 100 angstrom. They travel in straight lines like light. These X-rays, they can ionize molecules of a gas. When they pass through gases, they can ionize molecules of the gas. They are not affected by electric and magnetic fields as they do not have any charged particles. They are electromagnetic waves. They can be diffracted as per Bragg's law, right? X-rays can pass through flesh, less dense material, right? It cannot pass through bones. That's why X-rays are used to take pictures of bones. If you have a fracture, you go to a hospital or a doctor and they take an X-ray. X-rays can pass through flesh but not through bones. X-rays also can be used to find out defects in some construction materials. Okay, it can pass through less dense material but cannot pass through more dense material, so that is very useful. X-rays can also cause fluorescence. It falls on some material like barium platinocyanide, then that material emits light and that is called fluorescence. So these are the properties of X-rays. The most important thing for us right now to understand is that X-rays can be diffracted by crystals which act as natural 3D gratings for diffraction of X-rays, and we can use that to find the structure of crystals, the interatomic spacing. This is very, very important in crystallography to find the structure of crystals. X-rays affect photographic plates more strongly than normal light. Remember that. Now we will talk about Compton effect. Compton effect was discovered in 1923 by A.H. Compton. He directed a beam of monochromatic X-rays onto a block of carbon or paraffin. In carbon or paraffin, electrons are loosely bound to atoms. He found that the scattered radiation contains not only wavelengths of incident radiation, but also radiations of longer wavelength. This delta lambda is given by this equation. Delta lambda will be h by m naught c, 1 minus cos phi. H is Planck's constant, that we know. M naught is mass of electron, c is speed of light, and phi is the scattering angle. So this delta lambda Compton shift will be 0.024, we put all the values here and use appropriate units, multiplied by 1 minus cos phi, then you will get delta lambda in angstrom. So, in this lesson, we have learnt about Bragg's law, you learned properties of X-rays and Compton effect. Compton effect establishes the particle nature of light. Bragg's law is used to find out the interatomic spacing in solid crystals like common salt or metals. And X-rays, remember, are electromagnetic waves having wavelength from 0.1 angstrom to 100 angstrom.